I'm going to do a quick refresher on solving problems in 3D because we are going to deal with a little bit of 3D this year. So the example we have in front of us is the cliff is 50 meters high. So I'll quickly sketch my cliff here, and I know it's 50 meters. And here we are up here, okay, and the water down here. Person can see two boats, so I'll do a boat in green, and I'm going to move my other boat kind of off to the side here. So the two boats are out in the water, and one person can see it south 50 degrees west. So what I've done is given myself a bit of an axis on this side here, make it a little bit bigger, and I am standing right here. So the first boat is south. So whenever we're dealing with the vectors questions and you're given directions, you want to create your your Cartesian plane or your coordinate system here. So it says that it is south, so that means I'm going to face south, and I'm going to turn 50 degrees to the west. So I was facing south, and I turned 50 degrees towards the west, so I'm rotating, and that's where my green boat is located. And the angle of depression is 30 degrees. So I'm working with two views here. I have a top view and I have a side view. Okay. So south 50 degrees west, that's looking at the top where the boat's located. Depression of 30 degrees means that depression is when you are looking down. So there's my 30 degrees. And I can create a right angle triangle from this by either going up that way, or I could have went down as well, create my right triangle, and I know that this is 50 meters because that's the height of the cliff. So that's the first piece of information all taken care of. The second one, the second boat is south, so again I'm facing south on the top view, 60 degrees towards the east. So now I've turned my eyes, or rotated 60 degrees in that direction, and the angle of depression is 45. So from that horizontal, I have this triangle, also 50 meters high. The angle there is 45 degrees. So if I take the side view for 1 second here, I've created two right triangles. So I have one with a 30 degree and a 50 meters. And the second triangle I've created is one that's looks like this, right angle, also 50 meters, but 45 degrees. So that's my side view. So those are all linked together here. So I'm going to take my side view just to help you out. So that's the side view, and then of course this is all the information I have from the top view. So what do I need to know to figure out how far apart the boats are? So this is what I'm looking for. I want to know this distance right here. So we'll call it D. So how do I find that distance? Well, I need to know the arm that goes from the top of the cliff to the boat and from me to the top of the cliff. So if I was to go to my two triangles, I want to know this distance here from me to the boat, which would translate to this side in the triangle, from me to the boat, which would translate to this side of the triangle. So there are, and I'll label them length A, length B. You can really pick whatever letters you want. So length A and length B. So in order to find D, I have to know A and B. So I'm looking at this triangle right here. This one has what I want. I want to know D. The only way I can know D is by finding A and B, because really, if I take the information from this triangle, this is what I have. I have a triangle that I want to find side D. I know the angle in there is 50 plus 60, so 110 degrees. And I need to know two other pieces of information to solve for D. I can find A and B, or I need to find A and B, and the only place that's going to come from is over here with the two right angle triangles. So moving over there, let's solve for our values of A and D. So I said you have to be able to label your triangle. So on both right angle triangles, there's our reference angle. So we would have opposite, adjacent, hypotenuse. opposite, adjacent, hypotenuse. So we are looking for a trig ratio that uses O and H. So sine of the theta is equal to O over H. So sine 30 equals 50 over H. And I want to solve or isolate for my H value, which I should have switched to a variable A. So I want to solve for A. Well, A is equal to 50 over sine 30. Okay, so my opposite divided by hypotenuse. Hypotenuse is what I want. So there is my A value. From the other triangle, I also want to find H, and I know O. So almost an identical calculation. So opposite is 50 over, in this case I'll replace it with a B. Solving for B, I now have 50 divided by sine 45. So now I have that length. I have my A and B lengths. You'll notice I'm not using the calculator because you're not allowed to in the course, so we might as well get practiced with it right now. So we have enough information now to go back to our final step here. And our final step is to solve for length D. That's what we want to solve for. How are we going to solve D if I know A and B? Well, it's a non-right triangle. So it's a non-right. So that means I'm going to have to use sine or cosine. And I have a side two sides containing an angle. So I'm going to have to use cosine law. So using cosine law, remember A squared equals B squared plus C squared minus 2AB cos C. So just making my letter references match up. A is the unknown, so I'm going to say that's side A. And then I already have, we'll call this, B and C. B and C. So plugging what I know, I want to solve for A. So what I'm going to do is I'm going to take the square root of both sides. B squared. So B squared is, according to this, the A value. So bracket 50 divided by sine 30 squared plus the other value, 50 over sine 45 squared minus 2 times 50 sine 30, or 50 over sine 30, 50 over sine 45, cos of 110 degrees. So there we go. And this initial value, I should have switched it to a D. So looking back at the question, it only wants to know how far apart are the boats. So I only want to know the distance for the unknown value. So therefore, the distance will be the value of D. And that's going to be in meters up here. So you can see, don't have a calculator. You're not allowed to use the calculator in here because I'm just following thought process here. So that's all you need to do. You just substitute the values in as is, and everything's done. You don't have to wait to do any calculations. So there's your 3D example. The whole key with that 3D example is this right here, being able to break it into a top view and a side view. So there's only a couple questions to practice. You should have done this already at some point, the 3D questions, and if not, this gives you a little bit of extra practice, or at least a first time through. Good luck, and we'll see you in the next section here.